Hello and welcome back to the channel. So today we'll be looking at yet another problem on Leetcode. It has to do with our series, obviously the binary search algorithm. And this is problem number 34. It says find first and last position of element in a sorted array. Now there's already some hint there. If you hear the word sorted array, you must just know that we are talking about a binary search algorithm because one of the preconditions is that the array must be sorted. Given an array of integers nums sorted in a non-decreasing order, I don't care about those words, find the starting and the ending position of a given target value. See, so obviously, sorry, non-decreasing order means it means that it's sorted in an ascending order. It's as simple as that. And then now they are saying that the, the the target, you must look for a target. You are given a target and then you must look for it inside the nums array. Okay, so that should already tell you it's sorted in an ascending order, and then they were looking for a target, and then they are saying that if the target is not found, then the array must return. I mean, in the array, then you must return minus minus one array. See, so they're expecting you to return an array back as the result. You must write an algorithm with O of log n runtime complexity. Okay, so we are expected to run this in O of log n. So now this should tell you there's only one algorithm that is actually running in O of log n time, and then that is obviously the binary search algorithm. And so they're saying that this is a medium. So there's a reason why they did that, and I'll give it thumbs up. So they're saying that just look into the examples. If we have 5, 7, 8, 10, and we've been given a target of 8, so they're saying that they need the first occurrence and also the last occurrence of 8. So in this case, 0, 1, 2, 3, that is the starting point. This the first time we encounter 8, and then 4 is 0, 1, 2, 3. For this is the end time the last time we see 8. So if there was another 8 here, or a 9, or a 7 rather, or let me just say another 8 here, instead of a 10, it was going to be um, index number 5 instead. Okay. All right. So now let's look at another example, saying that this is 5, 7, 8, 10. Our target is 6. So if 6 is not found in here, so it means that we need to return an array with negative ones. Cool. I think that it explains a lot. So let us just go straight to the code. I'll do this just so you can see. Yeah, there's a little bit. Okay, cool. So now this is how we'll do it. We'll have one method that does something but slightly differently. Okay. Right. So let me just go straight to the code. So if we have public int, it's going to return the index, and then we say find first index. Yeah. Okay. First index, and then from there it's going to receive the same parameters there, nums and int target. Okay. So now we know that we must follow the same old binary algorithm style. So in other words, we must have trying to increase this a bit. So we'll have our left. We know our left is starting at 0, and then we'll have our right as starting from index nums dot length minus a 1 there, and then this time we'll have our index like this, which is equals to -1. Okay. All right, so maybe I should have index up here because it's going to disturb us there. Okay, cool. So we say while the left is less than or equals to the right hand side. Okay, so now if left is the less than or equals to the right hand side, what we need to do is we need to get the midpoint, which is going to be left plus into right minus left, and then we divide this by a2. Then that will give us the midpoint. Okay, so now this is where the trick lies. What we need to do is, we know that if the target is actually equals to the contents of the midpoint, then it means that we have found our index. All right, so our index will be equals to the mid here. Okay, right, now here's where the trick lies. So what we need to do is, instead of stopping, because normally what we do is we'll do a return here. So we'll say if the target is less than, instead of saying less than, we say less than or equals to the contents of mid. Okay, so we do a less than or equals to, so that we may be able to proceed. Then it means that our right hand side must move to right. We didn't find the value in the middle, and it means that it must be somewhere on the left hand side. So it means that our right will have to move to the left hand side of the array, isn't it? So otherwise it means that our left will have to be going to the right hand side, and then that's it with part number one. And then otherwise, if we found ourselves not able to get anything, we'll just return -1, which is an index in this case. Okay, now we have to do this the same way we've done this with the first one. We have to do the exact same logic and tweak it somewhere, and then we'll get the last index. Okay, so in this case, I'll just say the find last. Okay, and so the only difference here is that here we'll say that if target is greater than or equals to. Now if target is greater than or equals to, meaning that whatever we are looking for is not found or on the left hand side, it means that it must be on the right hand side. If it's on the right hand side, it means that our left hand side must be increased. Okay, we must go to the right hand side of the sub array. Otherwise, we know very well that our right hand side will have to go to mid -1, and then this should be pretty much it. Now we need to come up with a way to put this thing inside an array, because they are expecting an array as some sort of return. So they're expecting us to return an array. So if I have results here, it's equals to new results of size 2, and we have results at index 0 will be the left hand, or the, well, not the left hand side, but the first time around when we found the index of that particular number. So I'll call find first index here, and then we'll have to pass it nums and target. Okay, now we'll have to do the same thing for, we'll have to do this, I don't know what's going on. Why is it mirroring? Okay, they will do the same thing for the last one, so which is going to be a1, and then we'll do the same thing, and then what you need to do is just to return the results, the expected array that they want. So if we don't find anything, it's going to be -1 -1, so we'll return a -1 -1. Let us run it and see if whether our solution works. Hopefully it does work. We have a wrong case there. Let me see if we haven't done any. Oh yes, we have to call the right one here. Sorry about that. So I have called the find first twice, and it should be fine now. It has accepted our solution. Let's go ahead and do a submission. Voila!